All right, finally some true new stuff. Now, this video is going to be a little bit shorter than the last one. However, there is a lot of math language that you need to pick up and learn. So as we're going through this video, if you start getting confused and lost about the terminology that we're using, come back to the beginning, watch this first couple of minutes where we go over it till you're comfortable with these terms. So we'll spend some time on the most important ones and skip over some of that's not as important, but it is going to come up. So a monomial is a real number, a variable or a product of real numbers and one or more variables with whole number exponents. So what that means is a monomial, instead of, 18 is a monomial. Z is a monomial. Negative 4x squared, everything's being multiplied. The exponent is a whole number. That's a monomial. 2.5xy cubed, everything's being multiplied. Our exponents are whole numbers. That's a monomial. A over 3 is technically a multiplied by 1/3, which everything's being multiplied. That's a monomial. So another way to look at a monomial, and what you've probably used mostly in the past, is it's a term in a math sentence. And they're usually separated by addition and subtraction. So the monomial is each of the terms. Okay, each of those terms is something we call a monomial. You can combine these into what is called a polynomial. And this is the big one. A polynomial is a combination of monomials. It's a combination of adding and subtracting terms together. So polynomials, you take more than one term, add or subtract them together. That's the big walk away from this part. Polynomial, more than one term being added or subtracted together. Okay. The degree of a monomial or a term is the sum of the exponents of the variables. So, for example, this term right here, this monomial, has an x to the first power and a y to the first power. You add those exponents together. So this is a degree 2, a second degree monomial. This one, 27y to the fourth, z to the first. So that means this is a 5th degree monomial. 11 has no exponents. So it is a 0 degree monomial. That doesn't mean there's nothing. It just means there's no variables with exponents. This is called a constant. Has 0 degrees. Okay. You can add or subtract monomials by adding or subtracting like terms. This isn't new. The language is a little bit new, but you can add or subtract terms together by adding and subtracting the like terms together. What you need to remember is like terms are something like 5x and 18x. The variables are the same. Or 7a squared and 6a squared. The variables match exactly. What's different this year is instead of just having an x or an a or an x squared or a y squared, sometimes we combine more than one variable. So in number 3 right here, this example, we have 8 w squared x's, and we're adding one more w squared x. So my like terms, these are still like terms, but my variable is not just one letter, it's a combination of letters together. Same with this one. BC to the fourth, BC to the fourth matches. So for here, 8w squared x's plus 1w squared x's, well, that's just 9w squared x's. For this one, 5bc to the fourths minus 13 of them, 5 minus 13 is negative 8 BC to the fourths. So just like 5x and 18x, you're just adding or subtracting the coefficient, the number out in front, and the variable stays the same. So something you've already done, we just are adding some new terminology to it. So up here we have a polynomial. We have 1 term, 2 terms, 3 terms, 4 terms. We're adding them together, so it's called a polynomial. And it's shown in standard form. All that means is whichever term has the most exponents goes first. So this has an x to the 4th power, so it's a 4th degree. This has x squared, it's a 2nd degree. This has x, it's a 1st degree. This has no variables, so it's a 0 degree. When we write these problems or answers or questions, we try to write them in order. So if it asks you for standard form, it just means biggest exponent to smallest exponent. All right, let's try it. Well, a couple more things, sorry. Here's a few polynomials. We have 2 different names for it. We have a name using the degrees of the exponents, and we also have a name based on how many terms are in it. And this kind of goes back to, I guess it kind of shows your progress as you've been learning in math. Constants, this kind of stuff, just numbers, no letters, no variables, have 0 degrees. We call those constants. This was kind of like elementary school, at least early elementary school. And you only were learning one number at a time, right? You were learning 6 and 7 and 82 and 146. When there's only one term, we call it a monomial. So this is a constant monomial. If there is 1 degree, or in other words, there's 1 exponent to the 1st power, we call that linear. This was middle school. You dealt with linear functions and problems. You had 1 exponent, and a lot of times it wasn't just by itself. It was what was called a binomial, or in other words, there's 2 terms. So 5x and a plus 9. So there's 2 terms in it, 1, 2. What this year is going to look like is called a quadratic, which means there's something to the 2nd power. So an x squared. And a trinomial means that there are 3 terms, 1, 2, 3. Okay. This one, there's only 1 term, so it's a monomial, but it's x to the 3rd power, which makes it a cubic monomial. This one here has 1, 2, 3 terms, so it's a trinomial, but the biggest term has 4 degrees, so it's a 4th degree trinomial. We're not going to use that language a lot. This is going to come up. Linear is going to come up. You'll see trinomial and binomial a little bit. Those are kind of the big ones. Okay, now let's do some math. Write each polynomial in standard form, then name it based on the degrees and number of terms. So first of all, we need to simplify it. We have 6x squared minus 13x squared. So the x squareds, those can actually go together, combine like terms. 6 minus 13, that's negative 7x squared. And then I have minus 4x plus 4. Nothing combines with those because this is x's and this is no x's. And then to be in standard form, we make sure biggest exponent comes first. So negative 7x squared minus 4x plus 4. Those get smaller as we go. And this would be a trinomial because there's 1, 2, 3 terms. And it's a quadratic trinomial because the biggest degree is 2. This one, 2x minus 3 plus 8x squared. There's nothing to combine because these are x's, these are constants, these are x squareds. So we just need to put them in order. I'm going to put the x squared first, and it's a positive. And then 2x, which is positive, comes next. So plus 2x. And then minus 3 comes next. So again, this is a quadratic because there's 2 degrees, and it's a trinomial. There's 3 terms. 1, 2, 3. All right. You can add polynomials together, just like we added the terms together within this polynomial. I can take one polynomial, this one right here, and add it to another one just by combining like terms. Adding is great because 5x squared plus 3 plus 15x squared plus 2, we just look for the like terms. 5x squared, 15x squared, so that's 20x squared. And then plus 3 and plus 2 becomes plus 5. Some of you might remember this from 7th grade doing it that way. So 20x squared plus 5 is what I get when I add these together. When we need to be careful is when we're minusing in front of parentheses, because I'm not just subtracting negative 2w cubed, I'm subtracting this entire parenthesis. So there's 2 ways to do it. I'm going to show you both. One way is to do the old school, what if I had 35 minus 17? In elementary school, you'd put 35 on top, minus 17 on bottom. So I can do that. I can put negative 6w to the 4th plus w squared. And then you want to line up the degrees. So I'm going to minus a negative 2w to the 3rd. Well, that doesn't go here. That's going to go right here, negative 2w to the 3rd. A positive 4w squared. And a negative w. So negative 6w to the 4th, you just subtract up and down. Minus nothing is here, so I just get negative 6w to the 4th. Nothing minus a negative 2w cubed is a positive 2w cubed. W squared, there's one of those, minus 4w squared is negative 3w squared. And then nothing, 0, minus a negative w is actually 0 plus w. So that would be your answer. I don't like this way. This feels like elementary to me, but a lot of students do like to do it that way. What I like to do is take this negative and distribute it to everything on the inside of the parentheses. So I still have negative 6w to the 4th plus w squared. And then a negative 2w cubed becomes a positive 2w cubed. And a negative plus 4w squared becomes a minus 4w squared. And a negative w becomes a plus w. Now I just look for like terms. There's nothing else with a 4th power, so negative 6w to the 4th. I'm going to go down in power. So there's my 4th powers. Let's look for cubes. There's a 2w cubed, no other w cubed, so plus 2w cubed. Squareds, I have w squared right here, minus 4w squared. So 1 minus 4 is negative 3w squared. And then I'm left with a plus w at the end. I prefer to distribute and combine like terms. You're more than welcome to do it this way. Moving on. Multiplying a monomial and a trinomial. This is just distribution. You've done that before. And I think you should have even done it when, instead of just having like a 5 in front of the parentheses, you have a monomial. So there's more than just a 5. This one is a 5n in front. But we do it the same way. We take what's in front and we multiply it by everything on the inside. So I take 5n and I multiply it by 3n cubed. So 5 times 3 is 15. N multiplied by n cubed is n to the 4th, if you remember that from last week. Then I take 5n and multiply it by negative n squared. Positive times a negative is a negative. 5 times the 1 is 5. N times n squared, is n cubed. And now I take the 5n and I multiply it by a plus 8. So it's going to be positive. 5 times 8 is 40. And n is not being multiplied by anything else. So 15n to the 4th minus 5n cubed plus 40n. That's how I would do it. I've seen students use a box to distribute like this. So I have negative 8y cubed out in front. So they'll put negative 8y cubed right here. And then they draw a box like this. And some of you may remember doing this. And I've got 1, 2, 3 terms on the inside. So I'm going to break this up into 3 parts. And I write each term on top. 7y squared. I know I'm going fast. If this is something you've done in the past, great. Basically, it just helps you distribute. You take the negative 8y cubed and multiply it by each of these and write the answers in the box. So it's just distribution, but it's a diagram to make it maybe easier for you. So negative 8y cubed times 7y squared is going to be negative 8 times 7, which is negative 54. And y cubed times y squared is y to the 5th. Negative 8 times 4, negative 4, excuse me, I almost messed up. Negative 8 times negative 4 is a positive 32. Y cubed times y is y to the 4th. Negative 8 times negative 1 is positive 8. And we're left with y cubed. And then you just write it out. Negative 54 y to the 5th plus 32 y to the 4th plus 8y cubed. You can do it this way and just distribute and do a little bit of it in your head. If you like to write out the box, you're more than welcome to do it that way. We'll see this box come back in a week or two. Now we got to go backwards. So this is distribution. We can also factor out polynomials just by doing the reverse. So the way this works, and you're welcome to read through this if you want, but basically what I'm doing is here's my polynomial. 3x to the 4th minus 9x squared minus 12x. I want to pull something out of that and put it in the front of the parentheses. But it has to be something that goes into all 3 of them. So the first thing I'm going to look at is my constants. What number goes into 3, negative 9, and negative 12? And the answer is 3. 3 goes into 3 once. 3 goes into negative 9, negative 3 times. 3 goes into negative 12, negative 4 times. So those are left over on the inside. Then I look at my x's. X to the 4th, x squared, and x. I want to pull out as many of them as I can, but I have to look at the lowest exponent, which is this one, because I can only pull 1x out of the negative 12x. I can't pull more than that. So the negative 4, when I pull out the x, there's no more x's. X squared, if I pull out one of the x's, I'm only left with 1x. X to the 4th, if I pull out an x, I'm left with x cubed. I'm left with 3 of them. So my answer would be 3x multiplied by x cubed minus 3x minus 4. So you're distributing backwards. You just have to be careful to look at the constant, the coefficient, sorry, not the constant, the coefficient in front and the smallest number of x's. And this is going to be your greatest common factor. So when it says what's the greatest common factor, that's this number out in front, 3x. And that's just what I'm going to pull out. So this one, what's the factored form of 9x to the 6th plus 15x to the fourth plus 12x squared. I'm looking for the biggest thing I can pull out. So 9, 15, and 12. 3 goes into all of those. 3 goes into this one 3 times. This one 5 times. Positive 12 4 times. And now I'm looking at the x's. X to the sixth, x to the fourth, x to the squared. The biggest number of x's I can pull out is actually the smallest x, which is going to be x squared. So when I take away x squared, I'm left with nothing here. When I take x squared out of x to the fourth, I'm left with 2 more x's. When I take x squared away from x to the sixth, I'm left with x to the fourth. So my answer would be 3x squared, parenthesis, 3x to the fourth, plus 5x squared, plus 4. This concept is going to be huge this year. We're going to use it over and over and over again. So make sure you understand factoring, how to pull out the most that you can, which is weird because it's the smallest x that you pull out, because that's the most you can pull out of that number there. All right, so let's give it a try. 4x cubed plus 8x plus 12x. I'm looking for the biggest number that can come out, which is 4. So that leaves me with 1. That leaves me with 2 here because 8 divided by 4 is 2. 12 divided by 4, that leaves me with 3. And now I'm looking at my x's. And the most x's I can take out, again, is my smallest x, which is just 1x, which leaves me no x's here, because remember, I'm dividing it out. If I take 1x out of x squared, I'm left with x. If I take 1x out of x cubed, I'm left with x squared. So I get 4x multiplied by x squared plus 2x plus 3. If you're not sure if you did it correct, distribute and see if you get back to your answer. Take that 4x and multiply it by everything. 4x times x squared is 4x cubed. 4x times 2x is 8x squared. 4x times 3 is 12x. And that took me right back to where I started. So that is the correct answer. This one's a little bit tricky just because it's not only an x, but we're doing the same thing. I want to pull out the biggest number possible. So 9 and 27, that's going to be a 9 that comes out in front. So that's going to leave me with a 1 right here and a negative 27. If I pull 9 out, negative 27 divided by 9 is negative 3 left over. Now let's look at the m's and the n's. So m's first. This one has 2. This one has 4, so I can only pull out 2 m's. When I take 2 m's from this one, there's no m's left. When I take 2 m's out of this one, I'm left with m squared. I'm left with 2 m's. Now let's look at the n's. There's 3, there's 5, so the most I can take out is 3. When I take out 3, there's none left. When I take 3 out of this one, I'm left with n squared. So my answer is 9m squared n cubed multiplied by m squared n squared minus 3. And if you need to distribute to check your answer, you can. All right, simplify each answer and write it in standard form. So 5x squared minus 3x plus 7x plus 9x squared minus 2x squared plus 7x. We've got a plus, so we don't need to worry about distributing anything. Let's look at my squareds. 5x squared plus 9 of them minus 2 more of them. So 5 plus 9 is 14 minus 2 is 12x squared. Now let's look at our x's. Negative 3x's plus 7x's plus 7 more x's. Negative 3 plus 7 is 4, plus 7 more is 11 x's. And it's in descending order. My x squared comes first. So that would be my final answer. This one, y cubed minus 4y squared minus 2, has a subtraction. So we got to be careful that we distribute that minus to everything over here. So y cubed minus 4y squared minus 2 minus 6y cubed minus a positive 4 minus a negative, so that changes to a positive 6y squared. Let's start with our cubes. Y cubed minus 6y cubed. So 1 minus 6, that's negative 5y cubed. Now let's look at squareds. Negative 4y squared plus 6y squared, that's 2y squared. And then negative 2 minus 4 is negative 6. And it looks like even though this is a negative, all I care about is the exponent. So that's already going from the biggest to the smallest. So that would be your final answer. All right, and that should do it. Again, a lot of new terminology, but a lot of things that you've done. You've combined like terms, you've distributed, you've factored. Now we're just adding a little bit extra into it. We're adding some negatives. We're adding a few exponents. You are going to do homework number 3 on Math Excel. If you need help, come and see me before or after school. Come see me during class if you need to. You also have that Get Help button that you can use on the Math Excel program if you're trying to do this at home and someone's not there to answer your questions. Remember, this is due next class period. Go back and rewatch the sections that you need to, and good luck.